All right, what's up, y'all? We're looking at lesson 4.3. This is linear and nonlinear patterns. Linear pattern makes a line. Linear pattern makes a straight line, should I say. You can have all kinds of lines. You can have curvy lines as well. So a linear pattern is a straight line. So I have some data here in this table. I want to do a few things. I want to determine if it's linear. I'm going to write an equation. I'm going to write a graph. Let's go. So let me see here. First off, the first thing that I want to notice is, okay, for this increase in x, what's happening with my y? And if it's doing the same thing, if it's adding or subtracting the same thing, then it is in fact linear. So if I look at this from 5 to 8, it's going up 3. From 8 to 11, it's going up 3. And from 11 to 14, it's going up 3. So this is the same each time. So this is in fact a linear pattern. Now, when I'm writing my function rule, I'm going to do a graph in a minute, and that graph will be a straight line. But when I'm writing my function rule, that 3 goes in front of the x. And this is just like some of the Carnegie stuff you're doing. You're saying 3x, beautiful. To finish this off, the number that we put at the end is, usually the number that we start with or some value that we begin with. And this is the value when x is 0. So one thing that I can do here, it's pretty straightforward on this chart. I can just go up. I can say, well, what would 0 be? If I went up 1 more to 0, if 0 is already included in the chart, that's awesome. But here it is, and I left it off for this purpose to make us think about it. If I actually went up to 0, what would that other value be? Well, if I went back 3 more, that would just be a 2 there. So it's 3x plus 2. Now, you could just guess and check to get that number or use a variety of methods. And this value does work. When x is 1, put in 1 for x. 3 times 1 is 3, plus 2 gives me 5 for y. Okay? Let's check this one just for fun. I'm going to put in 3 for x, and I should get 11. I'm going to put in 3 for x, and I should get 11. So 3 times 3 is 9, plus 2 is 11. So that's good. So this function rule works. And you won't always have to write a function rule, but when you do, that is something you can think about. This number at the end is when x is 0, what will y be? And that works as well. If you put in 0 for x, this just goes away. So what will be left? Well, we are at 2. And this is linear because it goes up by that constant growth, and we'll see that it makes a straight line. So I'm going to graph this real quick. I'm just going to freehand it. It won't be perfect, but that's okay. Only my mom thinks I'm perfect, and she's delusional. So 5, 10, 15, 1, 5. You can see with my y-axis, I just move every 5 just for the sake of space. 2, 8, 3, 11, 4, 14, and there we go. It's important to space things. I didn't space these out very well, so my line doesn't look as straight. Make my points a little bigger here. So some good old advice is that you can always just make your points bigger. There you go. So if you kind of miss your point, just make your point bigger, and then you'll hit it. Beautiful. That looks great. So I did all this stuff with this graph. Okay. You have another pattern here, and it is not linear, so you can't do the same thing. But go ahead and kind of go through the same steps that I did. Think about this. You can, of course, just make a graph from the points. Try to create a rule for this. You have to be a little more creative. Go for it.